Okay, so when we're looking at exponents, we're just remembering the rules what we've already learned. So if we have a common base, so in this first example we have 3 and 3. So what this is going to do, it says write as a single power first. So what we want to do is we want to write it equals 3, and then we're adding our exponents. So this would be 3 to the 6th. And now we're just evaluating that. So 3 to the 6th is going to give us 729. All right, the next one, we have a common base. So we're going to write our base in, and the negative is inside the brackets, and that's important. Okay, so if the negative was outside the brackets, we'd have to not use that common base, but it's inside. So here we're going to have negative 2 to the 5. We're adding our exponents, and then that's going to be negative 32. And I'm just using a calculator to figure out these answers. Now division means we subtract if we have common bases. So here we've got 4 minus 1, so we write our common base, we get a 3, and that's going to be 64. This one's a little bit harder. Okay, so what we have to look at is we have our common base, and our common base is actually that whole fraction. We're dividing, so it's going to end up being 7 minus 4, which is 3. And what this is equal to, I'm going to write one more step in, is 1 to the 3 over 3 to the 3. Well, that's just going to be 1 over 3 to the 3, which is 3 times 3 is 9 times 3 again is 27. All right, last one, power of a power. When we have a power of a power, we multiply them. So we get 2 to the 8. And then we're going to look at 2 to the 8 and evaluate it and get 256. Alright, that's from before, and we did talk about negative exponents a little bit. I'm just going to go through this investigation that you would normally do on your own and kind of show you why we have 0, what the exponent 0 and things like that are. So if I were to go down this first row here, what we should notice is that in each case we've divided by 2. So copy them and describe the pattern. We're dividing by the base. Okay, so you're dividing by the base each time. So in the next case, rather than putting 3 to the 4 into my calculator, all I'm going to do is 243, and I would divide that by 3. I'm going to get 81. Okay, then I would divide that by 3 and get 27. Divide that by 3, get 9, 3, and 1. I'm dividing by 3 all the way down. Okay, the next one, we're dividing by 10. So we've got 100,000. That's going to change to 10,000, which is going to change to 1,000, which is going to change to 100, which is going to change to 10, which is going to change to 1. That's maybe the easiest one to actually see the exponent 0 is equal to 1 because we're just taking a 0 off each time. But what we're looking at is anything to the exponent 0, no matter what it is going to be 1. So any base raised to the exponent 0 is always equal to 1. Okay. Next. Now we're going to look at negative exponents. So we're just going to continue that trend. Okay, so we're dividing by the base. So here we started with 1. Well, I'm going to divide 1 by 2. Now I'm writing it as a fraction. Okay, and then the next one I would divide that by 2 again. Well, 1/2 divided by 2 is actually equal to a quarter. Okay, if you think of like a pizza, half of a pizza, if I divide that in 2, we get quarters. If I were to divide a quarter in 2, I get an 1/8. Well, what these are all actually equal to is this is 1 over 2 to the 1. This is 1 over 2 to the 2. This is 1 over 2 to the 3. Okay, if we do the same thing over here, we've got 1, we've got a third, got a 9th, 27. Well, that's 1 over 3 to the 1, 1 over 3 to the 2, 1 over 3 to the 3. And we can see the same thing here. 10, this is 1 over 10, 1 over 10 to the 2. I'm just going to write it as the power here. And then 1 over 10 to the 3. Okay, or 1 over 10, 1 over 100, 1 over 1,000. So what we're looking at here is if I have x to the negative exponent, all it actually equals is 1 over x to the positive value of that same exponent. Okay, so any base raised to a negative exponent is equal to, and what it is 1 over the value of the base. So 1 divided by the value of the base raised to the positive exponent. So what that really means is we're actually just switching the side that the exponent is on, or switching the side of the fraction. For example, this first one, if we wanted to make it a fraction, we'd make it 7 to the negative 2 over 1. So what we're going to do is we're just going to bring this whole thing, put it on the bottom. Okay, we're not actually moving that 1 up to the top, we're just moving the whole thing to the bottom, and we're leaving a 1 in its place. So this would become 1 over 7 squared. Well, that's 1 over 49. This next one, we're taking this whole negative exponent, moving it to the top and leaving a 1 in its place. Anything divided by 1 is still the same thing. So this next one would be 2 over 3. I'm making the exponent positive. That's 2 times 2 is 4, times 2 again gives me 8. And it would be 8 over 1, but 8 over 1 is just 8. Well, let's look at these ones. Write as a positive power and then evaluate. Same idea. If there's nothing there, put a 1. This is going to be 1 over 2 to the 3, 1 over 8. Same thing here. This one, 3 to the 4. And 3 to the 4 is 240. Oh no, sorry. That's 3 to the 5. This one is 81. Explain how the following are different. Well, this, if we were to expand them out, what I'm going to show you is the expanded out versions. This one would be negative 2 times negative 2 times negative 2 times negative 2. Okay? 2 times 2 is 4, times 2 is 8, times 2 is 16. All negatives is going to make that positive. This one is negative 2 times 2 times 2 times 2. Well, this one's going to be negative 16. And the last one is what we've been just working with, is 1 over 2 to the 4, which is 1 over 16. They all look very similar. They all have a negative in the equation. They're all treated very differently. If the negative's in the exponent, we switch the side of the fraction that it's on. If the negative's outside the brackets, like in the middle example, the negative value stays and we do the exponent just to the number. If it's inside the brackets, then we do negative 2, negative 2, negative 2, negative 2, like we did in the first example. Okay, finally, rules for positive exponents and apply them here. Okay, so what we want is we want to express as a fraction or a whole number. What that means is we need to make a positive exponent first and then evaluate. So this one, we're using our product rule. So our product rule says if we have a common base, which we do, we add the exponents. So 7 plus negative 3. Well, that's a positive and a negative, so that's going to be minus, so it's going to be 7 minus 3. 7 minus 3 is 4. So this is, 3 to the 4, I was just going to write that again, is 81. The next one, it's dividing. This says 5 minus negative 3, because in dividing we subtract. If we're subtracting a negative, that's two negative values. A double negative makes a positive. So what we're left with here is 5 plus 3, which is 2 to the 8. Now, that's a little bit confusing for some people. They struggle with that more than anything. But when we're subtracting a negative, it becomes positive. So 5 minus negative 3 is 5 plus 3. 2 to the 8 is 256. Then last but not least, this one is going to kind of look at what we did today as well. We have a power of a power. Well, we have to multiply our exponents first. So we get negative 3, and now we've got a negative exponent, so now we need to make it positive by switching the side that it's on, and then we evaluate. Whoops. 1 over 125. Okay, I'm going to give you one last example. I just want to show you if we have exponents on both sides that are negative and some positive. So if I have something like this, so write as positive exponent only, so write positive exponent and eval. So write as a positive exponent and evaluate. So if we had something like, so example, let's say 2 to the negative 3 times, I don't know, let's say times 4 to the 2, and then 2 to the negative 2, or no, let's leave that, and then let's say 5 to the negative 3. Okay, so there's a couple things that I want to do here. First, I'm going to leave the 4 to the 2 on the top. Okay, because the 4 to the 2 doesn't have a negative exponent. There's nothing else I can really do to it. So it's just going to stay there. So I'm going to just rewrite it because 4 times 2 or 2 times 4 doesn't matter. So I'm just putting it first. We need to switch the places of the negative exponents. This negative 2, or this 2, sorry, needs to go to the bottom. Okay, so what we're going to do is we're going to put the 2 on the bottom. So we've got 2 to the 3. The 5 needs to go up to the top. It's 5 to the 3. And now all I'm going to do is evaluate. So 4 squared is 16. This is 125. And this is 8. There's a couple different ways you could do this, but all I'm going to do is I'm going to multiply 16 times 125. So, and then I'm going to divide by 8. So this is going to be equal to 250. 16 times 125 divided by 8 is 250. Okay, I'm just showing you can move the exponents both top and bottom at the same time.